Welcome to my channel, everybody, and this is the chapter of relation, okay, to the class of 11 and 12. And you know the function like y equal to f of x and the relation between x and y, and this is actually called the relation. And some definition I have written. See, if A and B are two non-empty sets, when a relation R from the set A to the set B is defined as a subset of A cross B. So relation is a subset of A cross B and taken from A cross B. It means in the relation there are some elements which always all the elements of relation are lies on A cross B is there. Okay, and thus R is a relation from the set A to the set B implies lies that R is a subset of A cross B, and that is x comma y. This is a pair of observation. If we find A and B are given there, then we always find the A cross B. That is called the Cartesian product, and there are always a pair of observation like x comma y, and this belongs to R. So such that x comma y also belongs to A cross B. So x comma y, this pair lies on R. So in language we can say x is in the relation of R to y and write as x relation with R. Okay, if xy implies R, and also we say x is not a relation to relation R to y, then it can be written as like that x write R and y and cross this. So it means x does not related to y, and simply A and B are given here. For example, now find here A cross B, and that is a Cartesian product of A cross B, and there this is the pair of observation. See, A first and then B, that's a cross B. So element of A are always in first in the pair of observation, like 1 comma 1. Okay, see here 1 comma 1, and then 1 comma 2, then 1 comma 2, 1 comma 3. Okay, this is the Cartesian product that you know. So now this is 7 comma 1 and also 7 comma 2 and also 7 comma 3, and for 8 we get here 8 comma 1, 8 comma 2 and 8 comma 3 here. Okay, and this is the set of A cross B. There are the pair of observation, and see, if you in a question given that the relation is a collection of data from A cross B where this is x comma y belongs to R, where x is equal to y or greater than y. Okay, and what is the collection of that? See, x equal to y, so you should collect these. So 1 comma 1, and also x is more than y. So see, this is more than, this is from here. So that is 7 comma 1. See, x is more than y, and again 7 comma 2. Okay, see, satisfy this condition. Again 7 comma 3, again 8 comma 1, again 8 comma 2, and again 8 comma 3 also. Okay, so this is the relation under this case, and it is given in your question. And what is the find the relation where hold this condition? Okay, then you find this, and after that we want to introduce if like the pair of observation like 1 comma 2. 1 comma 2 does not satisfy to R, since in that case, given that the x is more than y, but here is x is less than y, so 1 comma 2 does not belongs to R, so 1 does not related to 2. Okay, so this is the meaning of relation. And now we have to find the domain of R, and also range of R. So in case of domain of R, and that is equal to the value of x is called the domain and y is called the range, and such that x comma y, this pair of observation lies on R. Okay, domain of R means this, and that is equal to the value which are 1, 7, 7, 1, and this is 7 here, 7 are not repeated here, this is 8, and this is the dome, means domain. And also range of R is here, what? And this is called y. And the pair of observation is x comma y when belongs to R. And what the value of y here? The second value, second. In the pair of observation, first value is called, this is the first value is called the domain, and second value is called the range of some relation. And here is the range, here is 1, comma, this also 1, this is 2, comma, this also 3, and nothing. And this is the range. And also relation is this, an inverse relation. Inverse relation. What is the inverse relation? Inverse relation. So what is the definition of inverse relation? So inverse relation is that when this is r to the power minus 1, and that is called y comma x. Okay, number in relation there are the pair of observation bx comma y, and then inverse relation are reverse. And when x comma y is belongs to R, so from that, and the pair of observation of relation is this, just the number are reversed. So this pair of observation are reversed. So 1 comma 1, if we reverse this, then 1 comma 1. But this is here in relation 7 comma 1. So in the inverse relation, we get here 1 comma 7, and same as 7 comma 3. So we get there 3 comma 7, and also here this is 8 comma 1. So we can write here 1 comma 8, and then 2 comma 8 also, and then 3 comma 8 also. This is the inverse relation. And among them, if we there is a question, find the domain of R inverse, and that would be also the this range are converted in a range domain, and this domain are converted in a range for the inverse relation. So we can write here DOM, dome of R inverse, and that is equal to the first value. In that case, in that notation here is y. So we can write here dome of R, where y comma x belongs to R inverse. Okay, and that value, this is the first value, here is y. So 1, 1, 3, 2. Actually, we can write here 1, 2, 3. Okay, and the range of R inverse, and that would be a this is x as that, whereas y comma x belongs to the R inverse, and then we can write here, and it would be a second values, that is 1 comma 7 comma, and this is R 8 here. Okay, so this is called the inverse of the domain. Okay, after that I also introduce the identity inverse and some others, and see empty relation or void relation. Means in the relation there was nothing, and that relation are denoted by phi, as is always a subset of A cross B. Okay, under A cross B. Yeah, A cross A. Okay, so empty relation is that. And universal relation, this is third and this is fourth. universal relation is what? And A cross B is also a subset of A cross B. Actually, they are same. A cross B is a relation which is subset also A cross B. Then we can say that that relation is called the universal relation. After that, the identity relation. Identity relation is that number 5. Identity relation is what? Say A is equal to 1, 2, 3, okay? Comma 4. Then IA means identity or collection data from A, that's why in suffix given that as A. So it can be written as x comma y, where x belongs to A. So this is x comma y, nothing, x comma x. So we can say right here, say A, I suffix A, and that can be written as like 1 comma 1, 2 comma 2, and also 3 comma 3 and 4 comma 4. Okay, so this relation is called the identity relation. Okay. Now here some other point we have to introduce here, reflexive relation. So reflexive relation number A, number B, symmetric relation. Okay. Number C, transitive relation. So about that concept, we want to saying that for a relation, let A be a given non-empty set. A relation R on a set A is said to be a reflexive if every element of A is related to itself. Again I says that let A be a given non-empty set. A relation R on set A is said to be a reflexive if every element of A is related to itself. Thus the relation of R is called reflexive, like that A comma A itself. Okay, A comma A for every A belongs to R. 1 comma 1, 2 comma 2, 3 comma 3, that type of relation. In a relation, it's satisfied. So you can say that type of relation is called reflexive. Like a mirror, if you stand in a view on the mirror, so you see on same view, so that's why A comma A. And symmetric relation is that if A comma B lies on R and implies B comma A also lies on R, same, then we can say where A comma B lies on A, then this relation is called symmetric relation. So see here, if 1 comma 2 lies, then 2 comma 1 are satisfied for the relation, then that type of relation we can say that is a symmetric relation. And the other point is here transitive. transitive, for the transitive relation, if A comma B lies on R and also B comma C also lies on R. B comma C here, this is C. C, A comma B, B as the end and B as the start here. So this implies that, so B are eliminated, then other B are eliminated, A comma C. So these pair of observation also lies on the relation. So see carefully, A comma B lies on R and also B comma C lies on R. So implies that A comma C also lies on R. So that type of relation is called the transitive. Okay. And the equivalent relation. What is the definition of equivalent relation? Some relation if hold these three properties, reflexive, symmetric and transitive. See. So if the three properties equivalent relation are called equivalent relation. When we call the relation is equivalent, when these three properties are hold, reflexive, symmetric and transitive. Okay. So now I also introduce some problem. For an example, I have given a problem here. A relation R is defined on the set of natural number n as follows. R is equal to x comma y and such that x comma y belongs to n, and the condition is here x plus 3y is equal to 12. This problem is copied from the our assembly book. Okay, so that R is transitive and antisymmetric but not neither reflexive nor symmetric. Okay, on n, and also find the dome means domain and range also. So see here, this is here x plus 3y is equal to 12. Now x find in the subject to the y, and that is 12 minus 3y, and take a common 3, here it is 4 minus y here. Okay, and n being a positive number, xy we have a positive number. If we collect the then the relation is there. This is x comma y, and where what is this? Now see, if we put here 1, so first natural number we take out 1, so it is easiest to the calculation here is if we put here 1, first natural number, then what we get? This is a 3, 3 3 is a 9. Okay, see again, if we put here 2, the value of 2 here, so in the second position value is y and this is called x here. Okay, if we put 2 here, then 4 minus 2 is 2, then 3 to the 6 here. Okay, and the other is here, if we put here 3, then 4 minus 3 here is 1, 1, 3 1 is 3. Okay, again we put here 4, then we get there 0, but this is not a natural number. So this is the relation. And now find dome of R in that equation. Find dome. And that is equal to x comma y, and this is called x, where x comma y belongs to R. So in that case, the dome are here 3, 6 and 9 here, and also range of R is that, and this is subject to y and x comma y. Okay, and the value of y is here 1, 2, 3. Okay, and find R inverse. R inverse, you know, the R inverse, then pair would be a that is y comma x is called the inverse of that. ABX comma Y, and you know belongs to R there, and so we can write here the pair of observation are reverse, and this is a 9 comma 1, so we can write here for inverse relation is 1 comma 9 here, and so 2 comma 6 here, and also 3 comma 3. Okay. So then domain of R inverse is equal to, we can easily write here 1, 2, 3, and now range of R inverse is equal to 3, 6, 9 here. Okay, see carefully and see here. Again, I repeat this question here. The relation is given that, and that is the logic here, x plus 3y equal to 12, and we have find here x is equal to 12 minus 3y and 3 times of 4 minus y, so relation is this. Okay, so dome and range is this, and inverse of inverse relation is this, and dome and range of the inverse relation is that. Okay, and the furthermore of this question given that, so that this relation is antisymmetric and also transitive, but not reflexive and symmetric. Okay, antisymmetric. What is the antisymmetric? It is transitive and antisymmetric. Okay, and neither reflexive and symmetric. For that, see here clearly from this view we can say this is an antisymmetric and also an transitive. See, in that case 3 comma 3, the rules of antisymmetric is that if A comma B lies on R, and if A comma B also B comma A lies on R, if then we get A equal to B, if whole A equal to B, so this property is called antisymmetric. Okay, so that's why if we take the number 3 comma 3 and another also 3 comma 3, we can take in repeat. So in that case, say A comma B like 3 comma 3 and also 3 comma 3, so we say that 3 equal to 3. So hold these. So that's why we can easily say that this is an antisymmetric and also a transitive. Now we have to show this is not a reflexive and symmetric. This is not an reflexive and symmetric. Why you can don't say this is not an reflexive? Since the each and every pair, this is there are the different type of number like 9, 6, 2 and 3, but only 3 comma 3. This is a reflexive, but other like 9, there don't get here 9 comma 9. Here is 1, don't get here 1 comma 1. So we can don't say this is not an reflexive. And same as symmetric. Same as we can say that this is not an symmetric also. So for the symmetry we know if A comma B hold, then also B comma A are hold for each and every pair. But if the pair be 9 comma 1 is lies on R, but 1 comma 9 does not lies on R. So that's why we can't say this is not a symmetric. So it is a clear view from the data we see that the relation is an antisymmetric and transitive, and this is not an reflexive and symmetric. Okay, so I think all of you are better understood. Now next point, we have to introduce the very important point to all of you. For our example, we have to show a problem. This is a hold and equivalent relation. So question is a relation R on the set of natural number n is defined as follow. Is that x comma y is a pair of observation lies on relation, okay, and this is implies that x minus y is divisible by 5 for all x comma y belongs to n, x comma y belongs to n, and prove that R is an equivalence relation. Okay. Okay. So for that, see here, for all natural number solution, for all natural number like a belongs to n. If we take here a comma a, that is implies that a minus a equal to 0, which is divisible by 5. So reflexive hold. Reflexive property. Okay, so number 1 point we have shows that the reflexive property is hold, and number 2 we have to show the property is here symmetric. Okay, again a comma b lies on R implies that a comma b, it is given that the lies on R. It means a minus b satisfied. A minus b is divisible by 5. Just it is given. Okay, not we have to show. This is given a minus b. As the pair of observation a comma b lies on R, so it means it is given that a minus b, if we get some value which is divisible by 5. Now we have to show the property is that b minus is also satisfied. Sorry, b comma a is also satisfied. It means we have to show this is a symmetric property or hold. So for that we can easily write like now a minus b, and that is equal to, we can write here b minus a, which is also divisible by 5. So implies that b minus a is also divisible by 5. Implies that b comma a lies on R when a comma b. So this property is called symmetric property. Therefore the property or hold. Okay. Now the next property is we have to show the transitive property. Okay. For that, we take some pair of observation like two pair of observation like here A comma B lies on R, and also it is given that B comma C are also lies on R. It means A minus B, this is given, these two are given. Okay, now we have to show B or C are lies, A comma C are also lies. Okay, and A minus B is divisible by 5, and this is here B comma C, and B minus is also so. So here we can take like that A minus B, and we added with B minus C, and this is we get B are cancelled, so we get here A minus C. So as this is divisible by 5 and these also divisible by 5. So sum of that two is also divisible by 5, and this is the common sense. So in that case we can say this is implies that A comma C are belongs to R. So the transitive property this is the property name is transitive. Therefore the property holds. So we see number one is reflexive, second is symmetric, and third is transitive. So R is an equivalence relation. Okay, so all of you are better understood. I think this is the good chapter for relation. See carefully. Okay, bye everybody.